You don't have to do the back.
Oh, there's the back. Let's do the back.
3, 2, 1. All right. In sake of time, I do need to call someone now. Because like I said, we got a timeline today. We got to do a lab. So here we go. David!
Let's go!
You have 2 marks. No, not 3 marks.
What did we get wrong?
The last one. I'll explain it.
I trust you.
All right.
This is
So,
what I got.
I'm going to go ahead and go over the answers real quick. Just to bring up,
2 marks.
as we go over this, first thing, on your test, coming up, quarterly, things like completing and balancing equations will be there. You need to go back and review your 5 types of reactions, how to do all that. It will be there. Construct a balanced equation. Do you have to memorize the formula for hydrochloric acid? Yes. So you've got K2CO3 plus HCl. When you do this double replacement reaction, your product should have been KCl, because K is +1 and Cl is -1 charge. And then you got to recognize when you have H with CO3, that actually always gives you a very specific product. You are supposed to memorize that it's water and carbon dioxide. And then you actually don't get the mark for this, like even though you have all the correct reactants and all the correct products, not good enough. Why? Got to balance it. So put a 2 in front of here and a 2 in front of here, and that should do it. All of the balancing in this class is usually not very crazy, like it's not intense balancing, you just got to remember to do it. The next question, so this was mark 1. The next question, calculate the quantity of heat. So what is the formula for quantity of heat? Density, yeah. And so M, what results in the amount of heat we're measuring is how much we have, right? That's the mass. The constant, and this constant is different for different solvents. But because all of our solutions are in water, our constant is 4.184. If we had a different solvent, we'd actually have a different C. Other C's exist, but just not in this class. So what is our mass here? 30. Remember, the volume is actually the same as the mass. You only add together the volumes if it's a neutralization, which I'm going to explain today in the quick lesson to explain the lab. Times 4.184. I saw many of you did get this correct. And times the change in temperature. The change in temperature is 26.2 minus 21, or just 5.2. When you work this out, you would have gotten, I'm just going to write what I got, 652.7 joules, or 0.6527 kilojoules, or any other unit you want, as long as you stated your units, because that's what it says. So if you want to do calories here, feel free. But it's not going to help you with the next question, right? So, part 3. Use your answer to 2 to calculate the enthalpy change per mole. When they tell you this, they're telling you the units. They're telling you that enthalpy is kilojoules divided by moles. They're actually telling you that in the question. They're saying it's kilojoules divided by moles. They say that right here. And so the kilojoules are 0.6527. And the moles of K2CO3 is what? Is that in the question somewhere?
Yeah,
0.02, right? 0, 0. And when you divide those two numbers, you get 32.7 or something like that. Kilojoules moles per mole. Now this is currently not correct. I don't have this mark.
The enthalpy sign.
I have to give sign. And they try to help you here. They're like, hey guys, remember, we want you to include a sign in your answer. You have to, even if it was positive, you have to write plus. For enthalpy, you have to indicate with a sign whether it's endothermic or if it's exothermic. So, how do we know? We started at 21. We ended at 26.2. The thermometer is the surroundings. So if the thermometer is hotter, that actually means that heat is leaving the reaction, doesn't it? The thermometer is the surroundings. So if the thermometer temperature goes up, and that's going to happen in today's lab as well, if the thermometer temperature goes up, that means the enthalpy sign is negative because it's exothermic. It's an exothermic reaction. It releases heat to the surroundings. We feel that, and the temperature goes up. Okay? Yes? So negative. And in the lab today, you're going to be asked for enthalpy, and you have to include a sign in your answer. It's going to be similar, not exactly the same, but similar. The final question here, explain why hydrochloric acid must be in excess. I noticed a lot of you were like, huh? And the lab will probably help you a little bit with this, but this is just kind of a standard question. And the reason why we would want more hydrochloric acid than this solid compound is because there is that water there that allows for the movement. If I just have solid and I don't have a lot of solvent, then it's going to be hard for the reaction to happen. And so the easiest way to say this is literally you just have to say to ensure the reaction completes. You don't have to go into any more detail. But it is because the HCl is in the solvent of water, and you need enough water to surround the molecules in order for the reaction to happen, because the reaction happens in the aqueous phase. If everything's in the solid phase, the particles are just solid and they're vibrating, they're not really moving, so they're not able to react very well. When we go over kinetics, which is actually in this unit, we'll understand that better. But it is because the reaction completes when you have that aqueous solution. All right, that was the bell work. The back is actually very similar. You didn't have to do it. I'm not going to go over it for sake of time. Like I said, we have to get to our lab. But I did want to just tell you there are some extra questions if you want to practice another one like this in the back page. Yeah.
Were all the questions worth a point?
What?
Were all the questions worth a point?
1, 2, 3, 4. Yes, everyone was 1 point. Good. Easy to calculate. Let's go ahead and go over. You'll notice it says Unit 5, Part 1B. I wrote this last night just to make sure we were clear for the lab what to do. So that's why it says Part 1B. We're still in calorimetry because that's what the lab's on. But I wanted to go over some things that are particularly important for you to understand the lab today, to be successful in the lab today. And we have to go over a little bit of graphing. If you didn't notice, I posted a video I wanted you to watch. If you didn't watch it already on Unpuzzle, please watch it at your earliest convenience. I wanted you to watch it by last night. It is a participation grade. I do want you to make sure you understand how to graph. We're going to go over it in a little bit, but the video helps as well. One of the things you could be asked to do in this class is to graph. And graphing shows up in the enthalpy lab. So if you get an enthalpy lab, there's a chance you get a question where you have to graph. And it also shows up in potentially kinetics, which is the next lab we're going to explore in a few weeks. And so today we're going to go over what enthalpy of neutralization is and the lab that corresponds with it. We've actually already looked at a couple of questions with neutralization. Whenever we have to mix the acid and the base together where we had to add those two volumes, that's actually neutralization. So I've actually already showed you a few questions of it, but let's go over the objectives real quick. These are the same objectives, except I added a part of this objective. The math, right? Calculate the enthalpy changes. I changed this formula to fit what I wanted it to be. This is not how it's written in the objectives, but this is how I want you to know it because this always works. M times C times delta T divided by moles. That is the easiest way to evaluate it. And then to do the sign, you do exothermic, heat out, negative, endothermic, heat in, positive. That's the easiest way to do it. And then notice that define and use the term. That is not a mistake. That's D. Meaning I didn't write A or B or C down. That's in Friday's lesson. I just wanted to bring up this specific one because it's in today's lab. So today we're going to be defining and going over what is the enthalpy of neutralization. If something shows up, N stands for moles. Just like in PV equals nRT, N is also moles there. Define. If Cambridge asks you to define, what does that mean? Word for word, definition, put it on a flashcard, right? So they could ask you for this definition. What is it? Before we get to that, if I recall last class, there were a couple questions we ran out of time. Just like 1 or 2 questions we ran out of time, so I reprinted them here. The homework I may do tonight to give you that additional time if you need it. Some students, a lot of students that are in tutoring yesterday found that they actually did it real quick without me even explaining it. But the idea is that there is a different type of calorimetry that you won't have an experiment for. Cambridge will not test you in experimental form for this, only in theory. And this is where you take a fuel and you burn it, and you measure the temperature change of the water on the outside of the steel can where the fuel is contained. We call this combustion analysis because the fuel, we're burning it. So you burn a fuel inside of here, and the water on the outside, the temperature changes of that. And that temperature change, well, that's part of the equation. Q equals M times C times delta T. So the only thing you gotta know here is that this mass of the water is the mass that you're using in your equation if you've got a combustion analysis. You don't use the mass of the gas or the fuel because that's in a different container, yes.
What's the point of the stir?
The stir is to ensure that it is thoroughly mixed so that even if there's an energy change, that it's the same throughout. And so the assumptions we have to make using this is that there's no heat loss in this setup, that standard conditions are being employed, and that the reaction does go to completion, meaning that you burned everything. So we have to assume that you burned everything, and then we can measure the enthalpy change of that. This is the process used to determine the amount of calories in different food items, because food are organics, and you can burn them. So they take food items, they burn them, they measure the temperature change, and they're like, that's how that has that many calories. This is the process. And so this was something we already went over. These are the practice questions I wanted to go over that were from Cambridge. There's just a couple of them that were at the end of last lesson, but I reprinted them so we could review them now. In an experiment, you'll only see this, I think, from Cambridge. A spirit burner. Do you know what that is? What is a spirit burner? What's a spirit? Do you know what a spirit is? I didn't know until I was in my 20s. It is. Spirit is an alcohol, right? People who are like, they drink alcohol, they know this way before I did. I did not know that. Because when you go and you order on the menu, I guess, at like restaurants, they call it spirits. Some people call it in the menu, they call it spirits. I thought spirits like ghosts. I was like, what? A ghost burner? Spirit is an alcohol burner, actually. So it means it's used to burn things like alcohol or other organics. What? Spirit. So.
You know, it's like when you're writing an essay and you don't want to sound like a third grader.
Well, alcohol sounds cooler than spirit.
I don't know.
Ghost or alcohol?
So if you ever see spirit on a menu at like Olive Garden or wherever, they're saying that that's alcoholic in nature. By the way, is used to heat 200 centimeters cubed of water by burning methanol. That's the spirit, is methanol. These are the results. Temperature of water, initial final, starting mass of the burner plus fuel, final mass of the burner plus fuel. First question, how many joules of heat are transferred to the water? What would we do to get this? What's the formula? Q was not asking for enthalpy at those points. It's just asking for this. This, right? Now here's where you have to be careful and understand what's going on. What is the mass here? Very good. Because it's the mass of the water that's changing, not the mass of the alcohol. Remember, the setup is the thermometers in the water. The alcohol's in here. It's measuring the change of. So very good. A lot of students accidentally put like these numbers. But the answer is 200. So 200 times what?
4.84.
Yep. Times what? 53 minus 25 is 28. All right, what do we get from this? Let's see if I solved it earlier. If not, I'll get out my calculator. I did not. $200 times 4.184 times 28 is 23,430.4 joules, or 23.4 kilojoules. We'll need this later, so I always do both. All right, so 23,430 joules. Are we good with this first one? Second question. How many moles of fuel were actually burned? How would we figure this out? Look at the data. Before we burned it, this was the mass of the burner and the fuel. After we burned it, this is the mass of basically that can and the fuel. How do we get just the fuel that was used? Subtract these two numbers. So you do 269.8 minus 262.9. Is that? Do they? Yes, they do, but it's not hard to get. 6.9 grams. What is the actual fuel here? What is this? Methanol, right? Which is CH3. OH. They do give you the formula in the question. So how do I get the moles from here? Moles equal gram divided by molar mass. Molar mass here is 12 plus 4 plus 16, which is 32.
I got it.
Yeah. Yes. So 32 grams per mole. And so how many moles do we have?
0.21. Something.
Okay. Are we good with this?
Should we round any questions?
3 significant figures is the standard.
Yeah, but like when you get to getting the enthalpy, use the rounded number or not?
As long as you kept each one to 3, it's okay. It's okay to use a rounded number if you kept each one to at least 3. All right, last question. Calculate an experimental value for the enthalpy change of combustion. So what's the formula for enthalpy again? Yes.
When it says experimental value, like the max amount,
That's a good question. When it says experimental value, it means this is the experiment. So we use this experiment to come up with what is the enthalpy change. So experimentally, we got this number, but that might not be right. Because could we have made mistakes? Heat could have been lost. You'll have some kind of percent error, like in today's lab. So experimental means you ran this experiment. This is the data that you got. What was your experimental value? If I look it up in a textbook, is this the actual value? Probably not. Because of those little things like heat losses, maybe some of the assumptions we made didn't actually happen, if that makes sense. All right, so kilojoule, we got that here, 23.4. Moles, how many moles do we have?
0.6.
216. Divide those two numbers. I got 108. I did 23.4 divided by 0.216. I got 108 kilojoules per mole. Is this right or not?
gotta
It's
add
not
the-
right.
the sign.
Does that have to include the sign with enthalpy? Is it positive or negative?
Negative.
Negative. Two ways to figure that out. Temperature went up in the thermometer, always negative. Energy lost to the surroundings, negative, exothermal. All right, so that was the question that we didn't do last class that we needed to wrap up on. Let's now talk about what we need to know to be successful in today's lab. So, you get to do a calorimetry experiment today using the foam cup method. And so, let's go over that real quick before we start the lab. I told you I wanted to get started by 1:15. So, I'll be handing out the lab paper shortly, but just a couple things to note beforehand. First thing, there's a definition here. It won't show up in today's lab, but could it show up on a paper too? It actually did on last year's paper too, if I recall. Like the students who got paper two actually got enthalpy neutralization on their paper two, not on the lab, they actually got it on paper two. And so, memorize the definition. Enthalpy change when 1 mole of water, and this is key, and it's key to the math you're going to do today. 1 mole of water is formed by the reaction of an acid with an alkali under standard conditions. What is a neutralization reaction? You know? Acid base, right? Neutralization reaction is reacting an acid and a base. But what are your products in an acid-base reaction? They're actually always the same. You may want to write it down. Acid and base makes water and salt, actually. So like, for example, if I have HCl plus NaOH as my example acid and base, what would my products be here? Water and NaCl. So neutralization is literally a double replacement reaction. It's a double replacement reaction between an acid and a base. One of your products is going to be water, and the other one you figure out from the ions here. So your standard enthalpy of neutralization, to get that value, is to say, what is the heat evolved when an acid reacts with the base? You're going to do something similar to this today. You're going to pour an acid and a base together, and the thermometer, the temperature is going to change. In order to get a good result, I have to give you concentrated acid and concentrated base, pretty concentrated. So safety, what do we think? Gloves and goggles. Make sure you're wearing gloves and goggles because you're working with sulfuric acid today. Pretty high concentration, it will burn you. And sodium hydroxide, a pretty high concentration. So gloves and goggles, 100% everybody needs to be wearing before we get started. Yes, Alex. As soon as David gets back. You can also think of it in this way. Delta H neutralization, where you see this little NEU2, NEUT means neutralization, and you'll just see these little signs for the different types of reactions you have, is the amount of kilojoules that are evolved divided by the moles of specifically water. So that's another way to remember it. So this is a definition to remember, and this is a formula to use, and you'll want to use this for today's lab. This is the reaction we're doing. You're going to be reacting sulfuric acid with sodium hydroxide. I have prepared these for you. And you're going to produce water and a salt. And so what happens is you're going to have to figure out your Q, right? Q equals M times V times delta T. But what's going to be provided to you is a solution of this and a solution of that. So in order to get the mass, what are you going to have to do? You'd have to add them together, right? Because it's a neutralization. Whenever you have a neutralization to get the mass, you're going to have to add the two solutions together. I'm going to tell you how you're going to get the delta T very shortly, but this is where the graphing is going to come into play. This reaction, I'm just giving you a heads up just so you know what's going on. So neutralization means acid and base is what you're provided. It's one of the types of enthalpies, meaning one of the types of reactions that releases heat or absorbs heat. Scary. So be asked to graph. This graph is going to be worth 4 points out of the 13 points in the lab. Go ahead. The graph is going to be worth 4 points out of the 13 points in the lab. So just to be clear. I want you to write a couple of notes on here. You can bring this with you as you do the lab. Like I said, we do want to get started by 1:15, so make sure you're writing these little notes. It'll assist you with the lab today. On the y-axis, go ahead and write temperature in degrees Celsius here. This is how it's going to be on your lab paper. They tell you y-axis, put temperature. On your x-axis, go ahead and put volume of acid. And you are told to do this in the instructions. When you get the lab instructions, they're going to say, write the temperature on the y-axis and write the volume of acid added on the x-axis. So what you're going to be doing in this lab, if you look quickly to the back, you should see a burette. The burette is actually going to be used to pour the acid into the base. You're going to be pouring very specific amounts. 5 centimeters cubed, then 10 centimeters cubed, then 15 centimeters cubed, so on and so forth. So like this. 0, 5, 10, 15, 20, 25, 30, 35, 40, and they actually ask you to go to 45. And at every 5 centimeters cubed, you're going to be told to measure the temperature change at that point. So when you add 5 centimeters cubed of acid from the burette into the base, you are stirring the mixture with your thermometer and record how hot it gets. Once you reach a maximum, then you add another 5. Then you add another 5. Then you add another 5. And then you're going to graph this data. And it's going to look something like this. This is not the exact numbers because I'm not giving you the answers. But it's going to look something like this. Yeah, it's every 5. Sure, like that. You're going to get something like this. You're going to have temperature. I'm not telling you the exact temperature, but you're going to have temperature increasing. And then at some volume, it's going to start to decrease again, meaning the reaction has finished. So what they're going to be asking you to do is they're going to ask you to figure out how much volume of acid was added at the end of the reaction. And so you have to do something called draw a line of best fit. If you watch the video, you should recognize this wording. A line of best fit means you need to write a straight line between the points that are increasing and then another straight line between the points that are decreasing. I can't use a ruler here, but you have rulers in the back that you're going to do this with. So you draw 2 lines of best fit. One of them is going to look something like that. It has to be a straight slope line. You use a ruler. It is not connecting the dots. What you're supposed to do is take a ruler, put it as straight as you can through the marks that are increasing, and then you draw 1 line up. And then you're going to draw 1 line. So like this way, right? You're going to draw 1 line like that. Kind of make sense? So it makes an X. At the intersection of these 2 lines, this is an important spot. This is the volume that you're estimating is where the reaction goes to completion. Does this make sense so far? So I'm saying, based on this fake data, that my reaction goes to completion when I've added 20 centimeters cubed of acid. And I can use that for calculations. There's one other thing you're going to have to get from this graph, the delta T. What is the temperature change? The initial temperature would be whatever it was before you added anything at 0, right? Whatever that initial temperature you take in the classroom is in your thermometer. And your final temperature would be at the completion of the reaction. So this is your final temp, or your maximum temp, right? That was achieved in the reaction. And your initial temp would be here. And you have to subtract those 2 amounts to get your delta T. So you're going to have to do that to do the math in this experiment. So you find the delta T by subtracting whatever these 2 numbers are on your graph. And then this is going to be for your calculations for like moles and stuff. later on. So how do we get points on this graph? And I took and I listed from the mark scheme so you know how they award the marks. I told you the graph would be worth 4. Like making this graph correctly is worth 4 marks. Here they are. Mark 1. If you label your axes appropriately the way they tell you to, and I gave you options of what it could be. That's 1 mark. Mark 2. What do we mean by suitable scales chosen?
Suitable increment.
Suitable increments of volume and suitable increments of temperature. So for volume, you notice how I did 0 to 45? That's suitable increments. For temperature, you can actually skip and say like, this is 18, your starting temperature or whatever, and then go up like this. They'll tell you in the lab that you need to choose your scale in such a way that your final temperature on the graph is 2 degrees greater at least than the one you get when you do your measurements. So I can't tell you the exact numbers, but you need to pick some kind of suitable scale. So it could be something like 18, 20, 22, 24, 26, 28, 30. I don't know what the maximum temperature is. So like I said, we have to first know what that is before we choose our increments. But the main thing is that you're choosing your increments in a way that the graph fills more than half the page on both sides. So pay attention to that. Your graph has to fill, when you choose your scales, how they're going to award the mark, is that your graph fills the temperature, at least is more than halfway filled with the graph. So if, for example, you chose this to be 30 and your difference in temperature is here to here, you didn't choose your scales right. You have to fill with marks that fill at least half the page on both sides, volume and temperature, okay? So this is just an example of what that looks like for Mark 2. Mark 3, all points recorded in the table, everything that you wrote down is here. And by the way, did you notice I wrote X's? When you are marking plots for Cambridge, you need to use X's and not circles. X's, not circles, for every plot you point. And then finally, Mark 4, lines of best fit, where you saw I did those 2 lines. You draw those. What does the word extrapolate mean? Extrapolate. What does that mean? Even though my marks ended here, I just keep writing. Like extrapolate means keep going. That's just keep going up afterwards. Extrapolate means just keep going on both sides. Your lines of best fit, just keep going, and then you find that point in the middle. That's Mark 4. So I lifted this, like I said, off the mark scheme so you know exactly what they're looking for on the graph. It's going to go into the math because you subtract these 2 temperatures to get the delta T. What do you mean? Not really. All right, so you are allowed to take the handout I gave you, the notes, to the back. Wait to go to the back till I pass you the lab paper, which I'm about to pass you the lab paper. You can work in pairs, 1 or 2 people. There's 9 tables set up and 17 students. You can work as a pair, no more than 2 students in each pair. Each pair is 2. So what's the first thing you should do before starting? Grab gloves, grab goggles, write your name. After I pass you the lab, pick a table in the back, read carefully, and you can get started. Yes. Yes. It'll be homework next class. Anything you can't finish in the class period in terms of the math, you can turn in next class period, but everybody does need to turn in a copy. All right, head to the back of the lab table before you touch anything. Grab gloves in. They're working with sulfuric acid. Yes, you can. Because they're going to move here. All right. So you've got an hour and 10 minutes. You must finish the lab before the end of class. Anything you can't finish here in terms of the math, you will be able to turn in Friday. You have to get 10 out of 13 marks for 100% of the grade book. 10 out of 13. Just
sulfuric acid.
not what they are.
Sulfuric acid.
I gotta put gloves on though.
Oh no, man. I'm a little thirsty today.
All right, make sure to put gloves on before getting started.
Yes.
Strong acids, strong bases. And the next thing, read your instructions carefully.
Anything happens to me is a real possibility.
Good.
Good.
That's for the big one.
Sulfuric acid. Yeah, you never cooked one. Let's go. I can just give you. Oh yeah, just grab it.
All right, one thing I'm gonna mention to each table, when you record, meaning, I'll even write that down. Record temperature. You can say 18.0 or 18.5 or 19 points. You have to end with the nearest 0.5. Just like with a burette 0.05, with a thermometer, I'm gonna say that's near when you record temperature, near 0.5, and you have to write either 0.5% or 0.0.
I would already be included anyway.
Make sure you are wearing glasses. Make sure you are wearing glasses. Yes.
Not like the lab.
The paper 5 is like experimental data.
And they will.
They'll give you the experimental data. Like they would already give you the data, and you have to make the graph based off of the fake data. Like that. We will review that, but after we go over content. That's like one of the things when we're studying for the year. No, it's not crazy. It's not crazy. You may want them for graphing.
Oh, so you are doing. Wow. Shoot.
You can usually get
No.
but then like, if you want to aid,
Go.
it's not something you really. The studying board is like the practice labs you do throughout the year, and then like at the end of the year. Alright, ready to get started? I was telling each table, I'm going to tell you. When you record your thermometer reading, you take that you have high 1.5. Write that down. Because it doesn't fit. Nearest to 0.5. What that means really is that it's either 18.0 or 18.5 or 19.0. You can't say 21. Like if you said 19.1, you lost that mark. Right? That's what I'm writing in colors. So I'm writing colors. So that is the thing. I'm giving you the warning. You'll have to run the edible 25. I lost my jacket. Yeah. Or you can just get a light bulb. You should clean your burette with water. That's wasting water. Let's come over here. They don't know how to work.
Let's talk about this video.
All right, over here.
I don't know why you couldn't
Are you This is your waste paper. If you have another speaker, so when you read it,
Okay, now place 25 centimeters. Okay, you don't want to do the outside.
I do want to all the answers.
Okay.
This is you're like that one like talk back to the people making a breakfast.
What?
Okay. Instead of 25 measurements, they're 25 centimeters. Okay, that makes sense. 25 centimeters. Okay, right. Can you please just go like 4 drops?
See how much I need to go. And that's how they go. They know the specificity of water is 1.6 because it measures the heat and then the mass of the water in your back. It's necessary to push people through, yeah. To calculate energy. Stress. Determine stress. Yeah. There will be a few of you use that to measure the 25. How is it not going to hurt? Okay, what you got? And to bring up something that I brought up. When you're measuring, and you're paid for it, when you get the sodium hydroxide, oh wait. Or you could write 18.5. You write 18.0, you could write 18.5. You're not allowed to write 18. So they want to write your number.
Obviously, you would read it this
There's a
way.
mark for them.
50,
Why?
40, 30.
I've been telling you, I never
You hearing numbers?
So you need to measure the temperature in the nearest 0.5 degrees. So each of these little lines are the phone color. And so it's either be right on the line or you estimate that it's in between. If it's in between the line, you do 0.5. And if it's pixel line or split pixel line, you do 0.0. So what do you think this is? Just by looking at it.
Just listen to me, I'll guide you. I'll give a little bit of background about the thing.
You gotta figure that out.
I want to ask you
Sounds
about
good.
So you
You wanna go 10.5?
no, or I don't think it's 0.5. Those are the from paper. Good? Did I tell you all about the temperature? So when you read the
what is the temperature? 16 or 17? It is 16.
Then, after you transfer it here, thermometer, he says, you're gonna keep it good, you're also gonna keep it and read the temperature of the thermometer. What I'll tell you is that when you read the temperature of the thermometer, you have to ground it. Each of these lines represents on the thermometer. So when you ground the thermometer at 25 degrees, you could either say that, for example, it's either like this is 15 right now, or you could say it's between 15 and 16 and it's 15.5.
Okay. Clean up your head. Clean it again in my face. I want to see it.
So if
Oh, is that this thing?
yeah.
Oh, my bad.
Yeah.
Okay.
Or
1,
16.
5,
So what was that?
0, 0.
17.0. After it's 0, so you may want to write on your paper now.
You can't read.
because that's good. Getting the other face for this period. You're red.
Okay, listen to me. Green would be red.
This one, see, I forgot.
Okay. Run 5 centimeters into the same. So. I'm not going to.
Okay, so we have the positive apparatus time. Let me give you. Oh my, I'll be right back.
If it happens, what is actually?
You already watched it, Alex? Have you already watched it? Or you were trying to watch it? Try this one. Try this one. Yeah. Sorry. You got that's 5.
It's a 0.
And then it says.
This is 0, right? 0. If it has left another time from
because when you start to the
but zeros are here, right?
zeros and you're gonna this and watch it start. So prepare yourself for that. You're about to start your reaction. Yes. It says no.
It says
I told you.
So don't be too hard to do because it's wow.
yeah.
Yes. That has things from. I'll be right there. Jen, if anybody needs,
Leave it in.
they're here.
If anybody else, okay?
You should, if you are going to see how
Actually, you should probably change it here. I think it needs a little I like to fill up the little triangle at the bottom.
We just write it down in the show. It's 55, right?
Wait. Hey, you guys got the
the meniscus is not.
Yes, it is. Miss Jennifer.
Oh, that's a I should have heard up for you. I'm sorry.
It's okay. No stress.
Would you say the meniscus is zero?
I don't know.
I told you.
Have you started the reaction? But that's okay. Alright, everybody be careful. There is some glass on the ground.
Oh, it needs more? I thought it needed less.
Damani, can you sweep this up? You may want to. Go ahead and do it. You're not tripping over it. Maybe you can work together and pick it up. And then you guys will have a total about how issues 4 and 5 are. You should be okay though. You just have to close it up. You should be okay. Just clean it up and then I'll help you install it. Okay?
There you go.
That makes me very Oh, the cleaners. Yeah, there's a little that needs to be done. Yeah, thank you. Usually she's pretty good about going around and making sure. Right. So I'll still see her for like an hour after school. So I'll just keep cleaning up the boat, but she should go here as well. Oh, yeah.
You want me to do it? I'd love to.
Okay, I filled up something.
I see a bunch of pieces. Okay, we'll come back. Okay, we'll come back for that. Now you can.
How do you forget?
If you need a new one, you can grab it from over there.
Should we restart?
I got it.
Whatever. We're great together.
Miss Jennifer. You're like, I added too much because I turned it to the right when I meant to turn it to the left,
Alright, I need to get you
and
one,
I
right?
opened it more instead of closing it. So I got half a millimeter too much.
Okay, did you have glass on the table that needs to be picked up still? I'll be back.
We mix them in there.
Yeah, but let me put it in the waste.
Yeah.
That's what I meant.
Right? No. It would be scary if you didn't keep up with me. So, and you got all these things.
Oh, it's okay. Breathe in, breathe out. Get ready to redo. Oh,
Report it out. Remember this.
you can have
Yeah. Good enough.
How did that happen? What are we on for the box bottle? And I'll start reading.
That's fine, right? Thank you very much.
Oh, so you did this and it has that, right? Like that? I understand. So hold from the bottom. So you add 5. You don't have to add it in there. You add it directly into the cup. The same time. You should add record temperature. So I was on the right track when I can grab it because 1:30. That's what I thought it was. That's your not control bar. Remember, it should be 30.0. Or do you need to get bigger? The nearest 0.0 or 0.5?
Thank you.
Good. Track. On track. Breathe in, breathe out. For practice lab, we don't stop. Try not to make it. I don't see it. Just in 25 here, and then you're doing 5. Stir. Yeah.
Right.
Where you at? Yeah, that's initial temperature. So that should be your initial temperature. It should be included in your graph, yes.
Put this back.
Another 5 is 10, right?
Who's close to the paper? Me? Okay.
Remember, you did 4.0. What's that? After the right. There's 8 R.
Just you and put it to the 25.
Just like the direct, you're saying,
I can stop to
when you say 28.0, you're saying, oh, it's on the line.
Thank you for the information. I would be on the
There's a mark on the left for that. You can, if they have questions, I have an effect, otherwise you can have then you can walk around, and if they need something, water, that's not very good. I guess that's, you can put the left to computer check. Now we're just having a shelf down.
16.
And
You want to look at it?
Don't look at the thermometer and
it's
tell us.
funny because I asked this person because the left, because they're very top.
It's 60 or 65. I'm pretty sure it's 60. I'm pretty sure compliment.
How can the temperature inside the room change? I think it's 17, but you guys said 16.5 last time. And it was 16.5 20 minutes ago. It's 16.5 minutes now. Okay.
No, it is so cold. That is cool. Like,
You didn't tell me.
I was gonna just stop, and then I was like, okay. Oh, wait,
This is milliliters of amplified.
remember, everything that I showed you, I showed you there would be an increase. So I kind of give you a heads up. It should either be an increase or the Germania, or not. So you have to like.
There's 0 milliliters of amplified. So smart, friend of mine.
You miss lab?
I love that.
We're gonna have another one in a couple of
Okay, here we go. You want to do it this time?
Yes, I want to do it.
You sure?
I don't trust you.
So well last time.
Don't you deny it.
You are. Come on. Oh, you're doing this so much worse than I was. Let me go slower.
You can.
That hurt me so much.
Yes, how many help? Okay. It's right at time.
It's not on.
Like, I agree.
Okay, sure. Why must we go?
You never know. You like, a box of random chocolate here for Christmas. You're like, what's in here? I don't know. If I find it, it's raspberry.
How and from this angle 22. 22.5. 22.5. It's in the middle.
What is that?
Rock, paper, scissors for it. Yes!
For once, first time ever.
Anyway.
make sure you work on your graph and get that done right after you're done so you can see if you got it correct. Remember, there are 4 marks on the graph alone. Okay. You may want to move.
I swear to God. Yeah. 10. It's on the line. Yes, yes, you are.
How are we doing? In the front. There's also a back part. One for that.
Bro, no.
I was right. Oh, what's the next one? You go. I didn't want to do one.
Did you finish? Oh, that was good. So you did the actual lab part in about 20 minutes. So now you got to do the graph and the calculation. Make sure to ask me with any questions you have. Make sure you have me check your graph. Remember the graph itself is 4 points.
We only need to turn in 1 copy so we could use one.
So like the graph first, the 4 right there. And then reading the graph correctly. And then after that is the graph itself.
Oh, you got it off my thigh.
From this angle?
Yeah, 30.
Yeah, the math.
Right, the graph is math. So here's the marks. These 3 marks, you don't necessarily need it. One of the marks like is your answer afterwards. You got it. You got it. Are you being a cheerleader? You guys just came out of math, right? You're in math class? Today? Oh, you can practice right.
I'm hoping for a C.
I'm gonna be happy if I get a C. No, that's actually so fast.
You're aiming for a T.
I know. I see it. No one's 40.
It's still at 30 minutes. I have a C in grade.
I don't know how. I only have a week if I didn't.
Yeah, you got it. That's all. Just don't come on Friday. And miss Wednesday. Yeah, just miss another week.
No. And then you can pour water.
It didn't move. I was waiting for it to move. It's still at 30.
This is wording of what do you think the other two marks are?
You already 0.0. Then the next one is 25.
So in this, the accuracy is your maximum temperature for your delta T. So that's how they determine the accuracy. You run the experiment. Basically, how would you ensure best accuracy?
That's 2. That's actually 2.
Wait, you broke it.
Yeah, he broke all here. That's 2. 2.
Okay.
I almost had it.
Fine, like 20 seconds. Like, I mean, it's not like minutes. It should be pretty quick because you have to then have the next one. And so I'm just saying that's how you turn the accuracy. You'll never know for sure when you take the exam whether you got the accuracy. You just not know. You won't know. But you can ensure that you recorded your data correctly. You can ensure that you wrote your graph. Does that make sense? Those 2 marks, maybe you got, maybe you didn't get them based on your experimental procedure. But you can get the full mark for the graph. This mark comes from reading the graph, the volume of acid added and the maximum temperature. That's what I was bringing up earlier, like how to read the graph. Well,
Yeah, that's what I thought.
Where that intersection is, the top is the dead center. Like going to the y-axis. You have to find the and that's by putting the graph. You have to do what I had brought up in the notes. Like make that
On the graph.
with a ruler. Like it has to be aligned with the line. Oh, you don't have to write the lines, but you're supposed to read the graph. Because when they extrapolate, they mean to go to so that's just to give you a little more. Then this is the math part. You calculate that. Hold, all of that.
It's going lower.
And then there's error, like a actual value error, divided by the accurate answer, what is supposed to be? The error divided by the true answers for the accurate answer, multiplied by the accurate. So it's like how far off are you? It's top number. And then the true answer, they're telling you here, the value in the textbook is that. Meaning that a ton of experiments have been run, and they have established that basically that's the right answer. If you don't get that, that means you have to do error in experiment. Then there's always been a small error. You've got to know this. So some of the key in this experiment, I almost because think about you have 5, time is passing. As time is passing, heat is continually leaving. That's your reaction actually. And then heat retains at the same time. And so there's actually, I would say there's probably a decent amount of error in the experiment. And that's okay. Like you should check that. That's part of the experimental design stuff. But yeah, I would expect you to error could be there are other experiments where you're like you did one earlier this year that I think it's only like someone got 3% error. And those should not have high error because you're like you're in the very, very the meniscus. Oh, you missed the last one.
Titration sometimes are. It's a skill issue.
You know, it's sensory class. I've never been able to show it here, but your other friends in the sensory class.
Oh,
Yes.
do it.
That's a new. What we're gonna do is the exam time. You're gonna get what's called a lab walkthrough. You're gonna go to 2 hours, you're gonna get back to the lab, and you're gonna have what that does, it gives you a feel for what that feels like, and also what it's going to make your strategy, like how you do better in the time. Last year, I had students, they got a U on that first walkthrough, and they presented that on the actual exam. Because they used it correctly, like you figure out, oh, okay, that's what I need to do to go a little bit faster to maximize my points, and then like I don't just do one walkthrough, we do a couple of them so that you improve. We'll do that when we get closer to that time. We're just going back to the practice steps of lab itself. So you can't miss your day to school them. So whatever day it's like your lab walkthrough is, whatever day you can't miss it. Because if you miss the lab walkthrough, like you don't want the first time you go for the exam to be that 1 hour prep. Because you are like, you're super smart, you know everything.
No, I carry the team. Every time you two work together, you still take one though.
Alright.
So what?
That doesn't mean anything.
It does.
How are we doing here?
We're more careful. And faster.
You know we have to restart it.
Yeah, we have to research too.
I was sort of. So someone gave us a stop.
It was you.
That way I know like where between 19 and so if you give me a bigger scary
They even look at me. Look at me in the eye.
you could do something like 19, 20.
We have work to do. We have to stop.
Go ahead. Betray me.
What they said the requirement was that 2 degrees above your max. So you have to go to 35. You have to be there. Does that make sense? So I would choose 2 degrees Celsius, and I would choose 19 there. Second period. All of your second period. That is for last.
Are you scared of gold?
So you lost marks on your graph. By the way, so maybe get out a pencil. I'm going to see if I have another copy. How have you lost your mark?
Just in.
Notice the maximum here. So it could be greater than that. It has to be a minimum of halfway. So that.
I think I know what you're talking about.
And so you want to do.
That's usually they do it with like rings.
20, 30.
You have to do all the hard part.
So like, you could choose
It's already pure gold.
5, 10, 20.
It goes through the teeth.
And someone here.
So maybe make it.
If I had to do it, this is so confident, like I might.
But you don't really want to do all the homework ones. You should know this.
Yeah, but this is like actually putting it into use.
Put it into use. You can try. Exactly.
I do have another copy, Sophia. Write your name.
You know the amount of people.
I don't have it.
You know Raymond was super expensive to buy, to pay for, to get on your island dance crossing. I was there.
Come on, let's do the math. Give me a paper.
And definitely. Don't be like me.
Oh my God, I'm so
Upside down. How are we doing? We got the idea now?
Are you looking like?
How are we doing on the graph? Remember, use pencil, not pen. Because you can use pencil for graphs, and if you make a mistake, you can fix it. You're not, they don't have other copies of pen. They have gifts. Like if you mess up on your graph, you can't ask, hey, can I have another lab paper? You cannot.
It's like I like wearing it on top of the feet, like it gives it like.
Yes. You read them from, oh, okay. So this point right here, what I would do with the ruler is I would like make a straight line down. That's your volume. Yeah, right. Well, it's like this. You write a straight line down. This is the volume at the intersection. This is the volume added of the atmosphere. So you read this one. That's the answer for the volume of the atmosphere. For the temperature, you do this one. So the temperature you go there. I didn't terrible. It should be on the like 30, right? So this is your 30. What was your initial text? The first reading. So you do 30 minus 17. And that's the information you need for the math later on. It's that number. So you read between 20 and 25 and you have that one.
I'm gonna make it now.
Yeah.
Did you get scared? I thought you got scared.
Notice you did that lab in 25. You did it in 20 minutes actually. 20, but then you gotta do all the rest of like the math in 2 hours. That's why I said the first time you practice it, it's hard, but then you realize the strategies you need to employ to go faster. Oh yeah. When you get the lab walkthrough, I don't put you in pairs. So like with this size of a class, I'll probably do the lab walkthrough on different days and have like one group one day and one group do the other day because there's 9 lab stations that I like to have set up, and then the other group like practices and that way I can focus on those 9 students that are doing the lab walkthrough. We also do one on Saturday. There'll be a Saturday that I'll set Saturday. Yeah, like you know how you have that you have to go to in Saturday school? For 8th chemistry students, they can opt out of this which one is so I would 3 hours of lab. So you do 3 hours of the lab and basically it's 2 hours of the walkthrough and the last hour is you go over the marks together. Like how you earn the marks and how you improve your strategy. So you can do that, you're allowed to with Ms. Kaufman and everyone in the administration that's allowed to do that every year. If you are in 10th grade or 8th chemistry or the 8th class, you are, instead of having to go to 9th grade to do math, you go to the lab and you do the lab. You don't have to ask, like, I already, that's just, you're in the class. So you still have to sign in the same way, but instead of going to English or math, you come to chemistry. They get your roster, so they'll know you're here. Because I have to submit a roster. Does that make sense though? So I do it on a Saturday. So you'll have walkthroughs in class, but you'll also have a Saturday day where you'll be able to come in and do a lab walkthrough during Saturday school.
Yeah.
Wait, you can choose.
That's good. It feels more than half, so it's good. And they said 2 degrees higher, at least 2 degrees higher than your highest value, so that's good. Where do you put degrees? I would put the unit degrees Celsius. Yes. How many how? Delta T. So the way to get this is to look at this intersection, go
Oh yeah.
down,
Okay.
and then go that way.
Oh, so use your graph to.
This is the fastest lab you all have ever done. where you all have time to work on the math. Typically,
How much time is left?
You've got 20 minutes left in class.
Oh.
That never happened.
That never, no, but that never happened.
We usually have like 5
In the
minutes.
lab, like it's 2:15 and y'all be like, I have to do one more titration. That's how the last couple of labs work.
Someone broke our freaking glass thing.
But like,
What's that?
remember also the video on how to draw lines. Because I'm telling you now that the video might. Really?
The fact that you can do that. What was your highest?
I told my test. What is it? Then I get skinny. Then I get fat. Wow. I'm up.
You use the pencil.
And we gotta jump.
Yeah, no, I'm
I'm gonna show you that.
No, there's many ones. There's like actual.
Oh yeah, you got this. How much out of that? You got 3 people.
Yeah, I was testing.
Concentration equals moles divided by
Can you please? No.
I want my freaking camera back.
There you go. I get you about to like hours master. That's it. Here you go. Back.
Yes, how many help?
You're telling me like the
Great question.
like it's just like
Did you get the
just the
data?
tip. You ever moved the Whoa! Of course.
You've got the volume. The part that you need to go back to always when you get a math question, go back to the beginning. Like all the information. They give you something else. They give you the concentration divided by multiplied by decimeter.
Oh, I see.
Concentration was multiplied by decimeter.
You spread the notes.
And then so it would be, one is your concentration, and you have to change the centimeters to stupidity. And that'll be from centimeter to decimeter, you move it to the left. Actually, now that you said that, it reminds me I need to give you back the test.
You're stupid.
Yeah.
Did you read it? Are you serious?
I mean, that'd be read from here, right?
Right, but my maximum temperature. Why are you like this? Why are
It's
you
a
like
maximum
this?
Stupid that I do.
For the volume, it's gonna be somewhere between 15 and
How am
20.
I supposed to do the math?
How was I supposed to do the math?
You didn't label your axis. Temperature, degrees Celsius.
You know, you
Oh,
should
yeah.
probably be doing your, oh.
Alright,
That's a mark, remember? The marks are there. All right, so I have your, I have some things to get back. Kat,
I just realized that I
Oh.
I put them in the wrong spot. I put them in the wrong freaking spot.
Anybody click on that? Becky? David? This is for unit 3, so you can have this to study over before the
Oh, I
exam.
didn't. Yes, unit 3.
I hadn't given
Put
this
it on the
back.
wrong side.
Sophia? This is the unit 3. I gave you back unit 4. And Stephanie. This is the
Use the answer Z to calculate the amount of moles of beer. How do you go from centimeters cubed?
That's what I'm doing right now.
Okay, so you have to change your stuff reader.
This, I get.
And then you have to multiply by
right?
You know, the point of
concentration.
it goes down.
Wait.
I'm all. I'm asking how you find grams. Centimeters cubed.
Oh, yeah. Yeah. When it came to scales, please don't do your graph. Same thing.
That's all you have to say.
You can ask for continuation booklet, but the continuation booklet have graph. They're line tables.
This is one of
Use the pencil.
What's the We'll be right now.
Make sure to have me check your graph.
Mr. Mike.
So Mike?
What you mean, wait, we just took the fourth one. Yeah, we just took the fourth one. Which definition was that?
I'm just concerned that you can just like still read it. That's how we scan it. But I think the way you've written it this way, they should interpret it. They got very petty, very petty. That was
I did the same thing. So.
They all followed what I did.
the leader.
Yeah.
Bring the bowl down with it.
Yeah, bring everything.
Yeah.
You got the power, number 2 down.
So you got the volume.
This answer will also be this right.
And that is the most.
So I just tried the atomic mass.
Body mass zero.
So notice that off from the picture.
Oh, you just found it one day and it was just. I don't know.
Like what?
You're that familiar with grapes that you just look at a pocket and you're like, you know what that reminds me of?
Yeah.
We're gonna go get it.
So then you use this point where the intersection is. You draw a line down for the volume of acid, and then you draw a line that way for the maximum.
Should be around
Is it 25? 25?
So at this point right here, and then there's
because you use 3
remember, you started with
So funny about that. Oh, yeah. How?
Because remember,
Hey, what do you get? Calm down. Nah. By the way, we're gonna finish this.
Oh, yeah.
You have to add. What? You do.
So, yes to 25. No. You have to add because it's a neutralization. So no to the 45. The volume to add to 25 is where the neutralization took place. Where the neutralization took place is at 15 centimeters. So you should be adding 15 and 25 because that's where you got the maximum temperature. So you do have to add some volume, but it's this one. Yes, can I help over here? Bless you. Salud.
What if we say, what if we can't use 18?
Yes.
Oh, what's wrong with you? So we just put the amount.
That's exactly what I was thinking.
We started at 12, right?
Just wait for the day and he's gonna like, look at how you
We're working together in this. Okay, what? 19.5. Yeah. So, just work out what this is, right? The difference between this size and
Double digit. You're gonna see Vincent with this in his pocket.
I want it bigger. I want it bigger. I don't think they get bigger.
Down your leg.
I don't think they
You have not seen the capabilities of the human body. Oh, wait, water.
No. You almost do it. You can't even fit 12 inches.
If you have like the trepidation, you did. Yeah.
I don't want to see it,
Never said no. I just You're asking the maximum chance of the bottom. Equals M times C times something C.
The length of my hand. That's, oh, I was thinking like my arm. I'm like, what? There's no way you can just.
You're supposed to add.
Out of 5?
No. Why don't you just do this and turn it into that? So 25 plus the height. Yeah. 25 plus the
That's the
height.
track. There's always a question.
We did. Wait, that's what we get.
There's always like the easy
You don't know when it's coming. I'm just gonna pop up one day and be like, this.
I'll put it on.
It's gonna go at the same time. Just be like, what do you think?
Yeah, exactly.
Oh no.
Because it's gotta be in between all your increasing points. It doesn't need to touch any one of them. So one of the ways that you shouldn't do this, I'm gonna look at the first last example. Don't do that.
What the?
What you're trying to do
You always
is
have
find
something going on.
between all 1, 2, 3, 4, 5, 6, 7 points. What is the line that is the best one? you need one, all of the points that are increasing. So I would say
What?
read regardless.
I was not saying.
Why is it? You read it?
No.
You see how I did it though? So mine says fit, you have to estimate. So this, I would say it's a little bit light.
Some factors in this
So it's a little bit off, yeah. I would redraw those lines.
Okay, and that's just the joules. It was just the joules.
Yeah.
Thank you very much.
Hey, this is what I was telling you to read.
No, Carrie needs to.
And then you subtract that from your.
And then this is just divided by 25.
They're asking for what? So the max temperature minus your.
Yeah, because it's moles.
The max temperature.
Sorry.
Yeah, it's moles.
I don't know.
Yeah, but one mole.
All right, you got about 7 more minutes. Make sure I see your graph before leaving. The math, turn in next class on paper. Turn in your work next class on paper for the rest of the class. You don't have to turn it in today, but you have to turn it in next class. Friday.
After a
No,
test.
but you do it at home and then you turn it in.
I take a math test.
My brain is fried. After the graphing, it's like every time I try to read, it's just like I'm not intaking what I'm reading. I'm reading it like 20 times.
Oh, the lid. Improvements.
So it says don't change the apparatus.
Oh.
You have to do something else.
It's an apparatus.
That means divide.
It's funny.
That's the measurement, right? So what else can you do?
I just read it.
One mole.
Oh, make sure you don't get
What?
Oh my God, no way.
For example, add smaller amounts at a time. Take more points, right? You could add smaller amounts at a time. You could mix the whole time, right? Without stopping.
18.
Constantly mix. So there are options that don't succeed. It's like, how could you do better? How could you do it better? That's just using apparatus.
Read the
How
question.
could you do better? They're like, I didn't do it though.
Ask them.
How do I know it's
One
25?
person that say, how do you improve this?
Because they're telling you, they're saying, hey, you could do better, right? What would you do better? You're used to being told what to do.
cubed, right?
Yes.
Yeah, one quarter meter. 25. Now, this is the density. Well, this is making sense.
It's always been said that.
It's always been said.
Why?
Every time I play with Leilani, it was
When they were, you're telling me that when you click them or you want.
Yeah, and then you stare into their eyes. You stop looking at your hand. Yeah.
4 to 5 seconds.
It's fine. It's
What?
range now?
1, 2, 3, 4. I declare them more.
Yeah, I declare a thumb more is another 5 seconds.
I declare.
That's all 9. 4 plus 5 is 9.
1, 2, 3, 4. I declare them more. 8.
You don't like graph seconds? 4 marks.
Yeah.
That's a lot of marks. That's a lot of marks.
Come on,
If a graph shows up, or you're like, there's a lot of marks. There's a chance.
6 to 7.
all you had was one.
It does show you.
1, 2, 3, 4, 5, 6, 7, 8.
That's not
I
fair.
win. I declare.
He's got the long range.
Your fingers like twice the fucking size.
Okay, I got you.
They're very specific. Yeah.
Oh!
Yeah. Concentration is moles divided by. But you're looking for you have concentration. You also have the DM.
Okay, so what about
Why do you matter? You could lie.
So it's 0.015 times one.
No, you matter.
Yeah. Oh, whatever number you have. So it's 0.015 times 1. Does that make sense? So for moles,
1015?
that's the decimeter cubed of the acid. Oh, It tells you close 15. That's your bulk. Centimeters cubed was called H2. But it's 15 centimeters cubed.
Thank you.
That's not That's not acid. Like that's a little bit of acid and a lot of water. So the formula here is actually bye. You can't get the water.
I have time.
Right?
I have time.
I got the same thing. Like we're volume is 0.05. So you never use the negative one because you don't have
Like I was under the impression today was my last day.
The annual listing that meeting on January 18th. Divided by mandatory AV Club Team Days on Friday for $1.
Okay, the numbers aren't necessarily crazy a lot of times. You just have to know what to do. The confusing part of these labs is not the actual process, but it's figuring out what's the right formula.
Okay. 10 to 5 is twice the amount of
You
time.
don't need it for here because what they're asking for is the neutralization
You
of water.
know you
It's
can
using
write
the moles of
1,700 words.
and so there's a keyword. Sulfuric
Oh, you're
acid
like partially done.
is diprotic. They tell you that in the beginning of the lecture. Diprotic means it has two H pluses. Every sulfuric acid
You
has
did it
two
for
H
me
pluses.
yesterday.
You know that one H plus makes that's what they're testing. If I have two H pluses, I will get so take this. Okay. You're supposed to take that and multiply by 2. Does that make sense? That's the concept. Yeah.
I'm confused about this.
That is the hard mark. This mark is
It's
wrong.
it is. Which one?
Which means girl factor is on 2, right?
But they were the ones that.
I didn't say anything.
You have to use concentration. Chemically equals bye.
Oh, so Lena was right.
You don't have to grams of acid. Because you have 15 centimeters cubed of H2O or AQ, but that's not grams. That's grams of solution.
When you get this.
That's not grams of pure acid. If you said that the grams of acid is 15, you're saying that that's pure acid, that there's no water. But it isn't water.
Walk by and prod me like that.
As if I don't feel their hand there.
Have a wonderful day.
Let me do the other one.
Well,
Easy
you
result.
have to do the enthalpy.
I'd rather be doing something for like.
You have to,
Okay, what about the equation you showed on
Yeah,
the board?
what is the answer?
yeah, you're gonna
I mean,
see that.
what is the answer? 100%?
The
The
geometry.
amount of what?
Oh,
Oh, okay. Let's see.
stoichiometry.
That's not good.
Who's ready for
What?
the test on Wednesday?
Stoichiometry. All right, time is up, but you can stay. I do have tutoring now. I do have tutoring now, so you can stay. Yeah, you can stay if you like, but you do not have to.
Hello.
Because it's 2:21, so feel free to go home or stay. Have a great day.
Look at me. Look at me in the eye.
Alrighty.
I also
That?
There is a
This,
sign
whatever you do,
on the
but
table for
whatever
free.
how do you do divide? Get to this. Okay? Wait, is this
Thanks for getting it today. Bye.
after you divide this, yes, this goes here. Okay? 7
Guys, right
25.
here.
Okay, KJ mole -1.
Okay, why do you
KJ
get it
mole -1. Mole MOL -1.
So how do you use the H2O?
And then the sign, you have to figure out the sign.
Oh, negative.
Negative, okay, the sign
Because
is
it gets hotter, right?
sign is negative. The
Sign is negative. Negative. You have to draw a negative sign.
Can we stop for a coffee?
A negative sign.
Bye.
That's the answer. How do you
Good
draw
luck with your math test Friday.
Well, my dad was calling me. I had to decline.
Also, try to take some brain
Put
cells.
this back. You okay?
There is tutoring today.
I knew it.
Okay.
I am a master of locating you
To
guys.
review over homework or any questions you have.
I was literally walking towards the door and I immediately see them walking in.
What do you mean?
Am I gonna keep the usual manifest?
Is it gonna be in
Like what? Pick a topic.
Like,
I'm pulling it up. Like, pick a topic. Pick a topic. Let me know.
Wait,
Now.
for
That's what they have to study for their test, for free.
skill issue.
Skillish.
It's the 10th graders.
David.
It's second period. I hear that word skill issue. Now it's like forever ingrained in my head. Is Luke and Jose Enrique. Is my
Jose Enrique is always gonna be.
Always.
always. Which one?
This.
Eating and pulling.
Oh yeah, me too.
Thank you for the pencil.
Me too, please. And
But they're gonna take.
face changes. I think it's like
Yeah, now,
Funny because you were.
it's only up from us. It feels like the menu at the restaurant.
What do you want? You said this.
But
And this?
you were talking about it. It's so basic.
The rest is
Let me
just
pull up that
getting
lesson so I can pull up the graphics up.
Okay, my master's for a long time.
Yeah, I have all, like, if you look,
I got it.
look at this,
I am
see,
looking.
like
I
this,
got
of
it.
all the lessons.
Oh,
I teach a lot. This is that's from August on, right? Because remember, I teach 3 courses, and every day, each course has a different thing to do.
chemistry second day.
Yeah, that's like the second day of school kind of thing.
It's like every day you have to like rewire for every period. We're here, we're here.
That is the one that carries the 8 point something. So I have to take the 8 points, remember, just after the unit exam, so I just write the date of when that is. Okay, hold on. We're here, States of Matter 2023. And then every year, like, I'll teach my lessons, so then I write the new year. This year, I taught this. So I don't forget anything.
It's so cool.
Alright, you said phase change?
I am absolutely.
Am I cold? No, because I run around all the time.
Oh, yeah.
Right?
So
but I'm still wearing a jacket. Which
Or
means
else
that I'm cold. If I wasn't wearing a jacket, I'm wearing 3 layers. So that's why I'm not cold.
Wait, is there the cleaning curve?
Yeah, so I heard phase changes and I heard this, right?
that.
This. So what do you want to know about heating curves or cooling curves? Besides memorizing. I guess I could like try to figure out some other questions to ask you.
There was
Um,
this like weird one. You know what?
Like this one? Let's try use the heating curve to give the total amount of heat to boil. Instead of melt, we did melt in class, to boil the substance at its boiling point. You said that was a weird one, right? Okay, so using the heating curve above, determine the total amount of heat required to completely boil this sample at its boiling point. So they give you some information here, so you have to read more reading. And they give you some, today we read, I had to read. Like the skeleton equation.
Yes.
You're gonna have to read tomorrow.
Miss, isn't it solid to the
boiling.
the liquid?
Right. So A, you have to basically memorize.
Yeah.
The way that a heating curve works is you, at the lowest temperature to the highest temperature. At the lowest temperature, what is the state of matter? For anything. It's a solid, right? Because the particles aren't moving, not enough energy to move. Like some of us in the morning.
And then after that, solid liquid maybe?
Then this is melting, technically, right? This is where melting takes place, where we are changing a solid to a liquid. So both of those phases are technically there. Because, for example, you're melting ice at that 0 degrees for ice. This is not ice. C. What is C?
He is liquid.
Temperature raises at the liquid phase, but it's getting hotter and hotter and hotter and hotter. Like a hotter liquid or a cooler liquid, right? So until you reach point D, when you get that straight line, that is the second straight line is always boiling. So this is boiling,
So the boiling
where you
point.
have, yep, boiling point, where you have both liquid and you have
Gas.
gas. And then at E, you just have
Gas.
gas. That's the heating curve. Cooling curve is exactly the opposite. Instead of going up, it goes down. So
Which should be
yeah, so I could, for example, because I told you, you don't know, but I told them today in class. For this topic, I'm only going to put it in multiple choice. So like the only type of questions you do with this is multiple choice questions. So what does that mean? I could ask you at what point do you have the liquid phase?
She told us
And
that
your
these two
multiple choice answers would be A, B, C, D, like that.
balancing equations.
So they're not meant to be difficult. You asked to see this. So using the heating curve above, determine the total amount of heat required to
It's even
boil. So the first thing is to establish where is boiling. That's at point G. And so boiling happens from minute 7 on this graph to minute 11. Following me so far? Between the 7th minute and the 11th minute, we're boiling. We're in the process of boiling. And so they tell you some information here to help you. They said every minute is going to be 15 kilojoules of heat for 1 minute, right? So how much total heat will it be for 4 minutes? What would you do?
Wait, why for 4 minutes?
Great question. 7 minutes to 11 minutes. Well, how many minutes is it boiling? So you do 11 minus 7, a total of 4 minutes is boiling. The difference between these two times. Because it starts boiling at 7 and it ends boiling at 11.
So
So-
you can't do 15 times 11.
Because if you do that, you're saying that it's boiling this whole time.
Oh.
Right? Boil, 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 boil. But that's not what it says. It says it starts boiling at 7 and it ends boiling at 11. So the time is 4 minutes.
you have
So
to do
4
15
times
times 4.
15. So 15 times 4 is 60.
60.
By the way, if there was a chemistry EOC, the questions would be kind of like that. Like reading the graph, doing the subtraction. They do a lot of like questions that if you can read, they do just like biology. It's like a lot of EOCs
for
focus
biology,
on reading.
The biology one was like not really much about what we actually learned. But I
It's
got
like
biology.
these questions that are like, a little bit off. Oh, because they tell you. It's 15 for every 1 minute. So that's given information. I know it's 15 kilojoules of heat for every minute. They ask for total amount of heat. So if it's 15 for every 1 minute, and I have 4 minutes that have passed, it will be 15 times 4.
And
You
what's
okay
the
with
next slide?
So it's just like knowing the phases. And then this is the cooling curve. We did this in class. Hi. Were there any of these that you wanted to review? Any question that you're like, what was that again? So you don't have homework, or what they're doing is throwing me topics off the list, like just to go back over.
Bye, miss.
Hi. Don't forget if you're here for tutoring, you do get that 5% extra credit, but you gotta make sure your name's written. So that means the maximum score could be 125 on the test on Friday for D-Day.
So I think I'm good. I have to do homework.
For what, this?
Yeah, I think I'm good already.
You're okay with it?
Yeah.
Anybody else, though, want any more questions here? Or do we want to go to the next thing, which is phase changes? How we feel about the curves? I was bringing up what I told you on 4th period. This topic only shows up in the multiple choice. Not putting this in the written part. Meaning, the type of question you could have is what point on this cooling curve represents freezing? And so multiple choice answers would be A, B, C, D, or E. So which point here would represent freezing? Because if you remember, and you just have to remember your states on a cooling curve, at the highest temperature, what would be the state of matter?
Done.
The highest temperature is going to be gas because things move
So it's
the
how
most with the most energy, right? So you start at gas and you end at solid. Freezing is from liquid to solid. That happens at point D, where liquid goes to solid. So that's the type of multiple choice question that you get if you're heating or cooling curve. And you have to pick the right letter. Any other questions with this?
Wait,
Because I'm saying it's only showing up on the multiple choice.
can you go back to the intermolecular forces?
Ah, I thought about it too at the moment. At what point? So I could ask you, looking at that graph, we did this in class as a practice question. At which of these points, and it will be again multiple choice, A, B, C, D, or E, are the intermolecular forces the strongest? And so the intermolecular forces are the strongest when the particles are closest to each other because they could be attracted to each other. If they're right next to each other, they're going to be most attracted to each other. Does that make sense? So A, B, C, D, or E.
Oh, A. And what
Does that make
about
sense? You're good with that?
and the Lewis structure?
There's going to be a process here.
Yeah.
I think what I actually heard. Did you want me to do phase changes first though? Or phase changes is in here though.
Yeah.
Are you okay with that now?
I don't like intermolecular.
So
Yeah,
so the first thing we learned.
Yeah.
Okay, sure. How about that? Do you guys also want to look at intermolecular forces? That's literally the first thing we learned. So I'm going back to the list. That is not. This is from current slide. This is like the list of like the main topics to cover. We just did like this, the heating and cooling curves, just to go over what is expected, what you need to know. And so the next thing will be intermolecular forces that has been requested. Now, I also said that this would show up, like all these topics are in the multiple choice. Every topic is in the multiple choice, but these two topics are the topics that are also in the written portion, these last two topics. So for intermolecular forces, I'm only going to be testing you multiple choice, like the quizzes. But on the extra credit, I will be looking for some of these questions where you might have to write it out. So you mentioned Lewis structures. And even for the multiple choice, you may have to draw the Lewis structure to come up with the right answer. So let's go ahead and take a look back at intermolecular forces. Okay. First of all, what are they?
Like what the intermolecular
What is it?
forces?
What's an intermolecular force?
Oh, like the types, like dispersion.
Okay, but what does that mean?
Like
What is that?
Dipole.
What does that mean? So how are the two species, whatever they are, substances, how are they attracted to each other, right? So it's the attraction between substances. The attraction between substances. And some attractions are stronger than others. Just like even between people, some attractions are stronger than others, right? There's some people you're like, oh yeah, we vibe. And then other people are like, please stay away. Repulsive forces there. So the attraction between substances. The weakest force is your dispersion force. So we arrange the intermolecular forces from weakest to strongest. That's how we arrange them. And to be able to predict which one is what we have, we actually have to draw the Lewis structure usually because it comes from the Lewis structure, which force you have. So even if it's on the multiple choice, you may have to draw the Lewis structure to make the prediction. And so the weakest force, you all said it, what was it?
Dispersion.
Dispersion. And what has dispersion forces? What?
Oh.
What has
Everything.
everything except for H plus. We mentioned that in class. But like pretty much everything. Yes.
Will this be in the multiple choice?
Yes. And well, the topic didn't. We had a whole lesson for it. Yes, we spent a whole day. It was a long time ago. It was a month, but we did it. Everything that has electron. which is almost there.
I multiply by 20.
What's the next one? That you were supposed to remember. And you could even be asked to arrange weakest to strongest, the intermolecular forces. I used to do that when I tested on the computer. Like I would have drop-down menu options where you have to do like arrangements. But I dropped the computer test this year. So I'm rewriting test. I told you. That's why I told you in class with the review. This is my intention. Is how I'm writing.
I can picture you like with the coffee cup holder, like.
Oh yeah, I'll have coffee. My 8 p.m. coffee. At the 8 a.m. one. Second period sees me every day with a coffee. They started bringing me gift cards for like, and then you brought me the cup. I was like,
Yes.
Is that a roast? Did you roast me?
No.
Where's that cup? It said, please take away. I'm addicted to coffee.
Oh,
That's funny.
That's what it said.
It's funny.
I was like, wait a second. I'm gonna drink my culadas in that. Thank you, though. We appreciated the joke. I showed Mr. Run. He was like, dipole. What has dipole forces? By the way, I can't be happy without coffee. If you've ever seen me on a day without coffee, I've had like one this year. My mood is just completely different. You just see like a low energy, like version of me. And it's like, please, I want to go home.
Yeah, it's like partial charges.
So what is it?
Or non-polar.
Partial charges, okay. Which means it has to be polar. Uh-oh. How do we know if a polar molecule is polar? How do we know? What are we looking for that? What were the keys?
The pairs. Like the scale.
Unshared pairs.
Yeah.
Right.
Oh, the unshared pairs in the Lewis. That's true.
And like the scale
Or
thing.
not symmetrical. I'm not giving you electronegativity values. You don't need them. So you have to use this. What I am giving you is the polyatomic ions, and you're welcome. As those who had the lesson today thought, that will be a great benefit to you.
Oh, damn.
It would be such a headache. It's already a headache. It would be such a headache. What's the next one? Dipole. Strongest.
Hypo.
I'm not putting it on the test. I want you to be aware of its existence. It shows up like super infrequently in ACE. Like they'll mention the words in a question, sometimes like in the multiple choice. But it doesn't show up like these do. So this is where my focus, that's why the whole entire lesson was like on this, because these are the main ones that are tested. Ion dipole exists because when we go to that section on solutions, that's how things dissolve in water, is that the water polar dipoles attract to the ions. And so that's what the ion dipole is. Hydrogen bond.
The one that's like connected to.
I could ask you if ion dipole is stronger than these.
FON.
And it is. Hydrogen bond is H connected to F-O-N, right? Actually bonded. And because these are the three most electronegative elements, you get a bigger dipole. Because you get a bigger dipole, it means greater attraction. So that's why it gets its own category. Because like water is its own special thing that has its own special properties. That's why in biology, like you study water. If you study marine science, you study water because of its unique ability to bond, because of that great difference in electronegativity. So what you're going to be asked to do primarily with intermolecular forces is I'm going to give you a compound and ask you which one does it have, like which is its strongest force. And so if I give you, are you good with this? Can I erase this?
Yeah.
Well, actually,
You need a picture? Yeah. Because I want to show you practice questions because this is the concept, but you want to know how you're going to be testing.
In case I lose the paper.
No, I don't want to do that. I did it last time.
You take a picture?
So I'm going to discard the annotations and link back. So let's take a look at questions. The first type of question you will be asked is, what is the strongest intermolecular force for interactions between following substances or molecules or whatever substances. Why do I use substance? Because I don't want to specify what I'm talking about. Substances, if I could be working with atoms, I could be working with ions, I could be working with molecules, but I don't say that. So I say substance. That's Cambridge approved. We can say that. Otherwise, if I say atoms, then I have to do a single element every single example. So A. F2. What is the strongest intermolecular force in a bunch of F2 molecules? Because it has electrons, but it has no difference in electronegativity. So the answer is dispersion. And so on a multiple choice, this is easy to put as multiple choice because I could literally say your choices are A, dispersion, B, dipole, C, hydrogen bond, and like D, for the heck of it, ion dipole. And it's like, no, it's dispersion. Do you get what where I'm going with this? All right, so carbon monoxide. Spice it up a little bit. Because it's not symmetrical. They have different electronegativities. So oxygen is much more powerful than carbon because oxygen is electronegative. So the electrons will shift to oxygen. So this will have like a partial negative charge. I will have a partial positive charge. And therefore, we will not say dispersion is its strongest force. It has dispersion, but it's not the strongest force. The strongest force is let's do. I'm gonna write the Lewis structure.
Yeah, how do you do the Lewis structure for carbon monoxide? Forgot.
You're not being tested on it. Do you really want to know? You did that last test. I'm gonna tell you. You asked.
You're opening Pandora's box.
This sweet single one. Double one.
Oh, you have to give? I forgot.
Am I gonna test you on that already? You asked the question, so we did it. That is the answer. So I'm giving you a Lewis structure for this one. Is this one, and this is by the way CH2O, which I have also asked you to do the Lewis structure similar to this before. It was in one of the last unit. Is this one's strongest intermolecular force dispersion, dipole, or hydrogen bonding?
Yeah, but
Very good.
it's not connected to it. Oh.
So this is how I can spice it up to trick you if you're not careful. In order for it to be hydrogen, and I also spiced it up, and this is how Cambridge did the right stance. They're like, they had a dispersion, they had a dipole, next one must be hydrogen. Nope. That is not how they write Cambridge exams. I've studied a lot of Cambridge exams. Dipole. We're good with that because hydrogen is actually not directly connected to oxygen. So it's polar.
Can they just give
Polar.
can they
Because oxygen is more electronegative, so the electrons pull up. So this would be negative, and this would be the positive side. So it's polar, so it's dipole, but it's not hydrogen bonding.
Wait,
Yes,
so if
Cambridge will give you that. And they could ask you what is the strongest intermolecular force.
If it's polar, it's always gonna be dipole.
Because there's a stronger one, but it's not molecule.
Oh,
It's either dipole or hydrogen bond. You have to figure out which one it is. So what about this next one? Let's do.
no, she's not gonna do it.
Yeah, she's gonna.
For this one.
Okay.
So you have to draw the Lewis structure. So I could do this where I give you the formula. You have to write the Lewis structure to come up with it. So has to be like this, right? Right? Now you're doing the same thing for all the dots.
So it's over.
That's the loopiness for being tired. You're right.
Wait, why did I do like that?
So, bringing up another point. Hydrogen is there, but it's not hydrogen bonding because it has to be hydrogen directly connected to fluorine, oxygen, or nitrogen. Not even there. So hydrogen bond should not be in your list of things to answer. Good with that? All right. Anything else you want to study in intermolecular forces, or do you feel okay about this?
Yeah, I think I'm good. Like,
So I have.
Wait, what happened with the what's the boiling point and then
Didn't we do that? Heating first?
no like it's a little line to like see which type.
oh, the solubility one.
Yeah.
Solubility curve. Take a look at those. How are you all feeling about solubility?
I
How are you?
forgot.
You want to review it? How did you feel about intermolecular forces? Good with that? Brought it back to memory? Okay. So let's go over. For those of you who came a little bit late, I was just showing them. This is how many lessons I've taught since August.
A long time ago.
Because every day I load up the lessons like for that day, and so I teach 3 classes of chemistry, so there's a lot of lessons. Multiply your class by 3. That's how many different lessons we're talking.
Stereo.
And like you guys could be learning completely different things. Your class is learning about no, just this set. But your class is learning about balancing equations, Edison equations. AS chemistry, which is the second year, they're learning about heat. So heat, it's called enthalpy, but they're learning about heat. Like if I mix a reaction together, how much heat is released or how much heat goes in. That's what they're learning about. And then A-level chemistry, they are learning about transition metals. Remember, so we don't talk about them? In the 3rd year class, we're talking about them. So
Stereo is something.
yeah, stereoisomers, that's part of it. It's chemistry jump scare. Proud of your son. You said stereoisomers? Oh, it's here. Chemistry jump scare.
Oh my god.
Where's it? Here.
Oh my.
It's a chemistry jump scare. But it looks actually like some of those, right? We have done that before, though.
Yeah.
We know how to interpret that at least. We know that wedge means you, and dots mean going back. Yeah, but it looks scary until you realize there's just certain things that are in the question. But yeah, then we call that a chemistry jump scare. What?
Nah, I think it's B.
It's
I didn't read it.
D.
I believe it was B. Whoever guessed B. Okay, so we wanted to go back to, you told me solubility, right? So I gotta find that lesson.
You have so much PowerPoint.
Yeah, this poor board, I should probably shut them off.
Still running.
It is for the most part until I get kicked off the internet.
Yeah.
Alright, this was what we're talking about. Alright, so solubility.
Will we be given that chart?
If you have a question, it will show up exclusively in the multiple choice. And if you have to make a determination, you will be given this chart. Like it will be provided to you in the question. And so what types of questions could you be asked here? You could be asked, how many grams, I'm just gonna put up a question. How many grams of KVR can dissolve in 200 grams of water at 20 degrees Celsius? This is the type of question, we had a homework on this. How many grams of KVR can dissolve in 200 grams of water at 20 degrees Celsius? So do you remember what to do?
Oh, yeah. Look at
You have to look at the
20.
chart.
Find the right thing. So look only at KVR, don't look at everything else. So find the right graph. That's going to be this one. Go to the right temperature. That's going to be should write a line from here to here. So far, so good? So now we write a line going to the other axis, the y-axis, and that tells us that approximately, and it's multiple choice, and I'm not gonna be like someone who's like
69 or
63 or 64, like those won't be up. It'll be like clear if you did the procedure, which one I rounded to in the question, if that makes sense.
61.1.
So,
Literally, we had a biology question that was in a quiz that was like about a bacteria of like something with a P, and then it literally showed like the thing going like a curve going like that and then straight. Then it showed.
I'd say this is 65 maybe?
Yes. Yeah.
65? If I'm estimating this is 65. But what does that mean? 65 grams of KBr dissolves in 100 grams of water. So you gotta be careful here, because the trick is you're being asked how many dissolves in 200 grams. So if I have double the amount of water, then how much will dissolve? It's the idea. That is the idea. And that's actually a lot of the math and chemistry, is that type of thinking. Understand, if I double this, that means that this has to be double as well. Because this graph tells you the amount that dissolves in 100 grams.
Yeah.
But you have 200 grams. And 200 is twice 100. So the idea is that you would literally just do 65 times 2. You're allowed a calculator. It is 150. So this is the style of question that you will be asked with the solubility curve. The other style of question is I could give you an amount and I could ask you if it's unsaturated or saturated. So go ahead.
Like the amount that can be dissolved is equal to the amount that you're dissolving in the
Saturated.
saturated.
So like if I put exactly 65 grams or 130 grams in, it's saturated. Any number less than 130 is unsaturated. Any number more is technically still saturated, but now you have like stuff at the bottom, because no matter how much you stir it, it just ain't gonna do anything. Like it's not gonna go in the solution. Water can't surround it anymore. Are we okay with that? All right. So the other type of question that I could ask you here is, if I put 15 grams of NaCl is placed in 100 grams of water at 40 degrees Celsius, is the solution, multiple choice, A, saturated, B, unsaturated, C, supersaturated, blah, blah, blah. I'm gonna put a fake answer. D.
Undersaturated.
I don't know. If you see like a random, if you see a random answer, that means I got bored when I was making your test, and I'm just like, I don't even know. Skill issue. Like, if you see that answer, don't choose it. Just meant I ran out of.
Somebody chose it right now.
You know, it's not impossible. Like just Christmas tree the test, which means like picking random answers. Please don't do it.
Wait, unsaturated, supersaturated, and saturated.
Yeah, those are like the real 3 answers, like possibilities, and then anything else I put would be like random choice that is irrelevant. So, well, which one is it? How do we figure this out? Graph first, right? So you've got the graph, you find the temperature, and you find the substance. So NaCl at 40 here. So we go here. Are you allowed to use a ruler?
Probably.
Sure, and your test is on paper, so why not? Now, how many grams does this say? What's your estimate?
I think
I say it's less than 40, because right isn't 40 there?
36.
Okay, guesstimate 37. It's a guess. Because, like, that's why I said I can't give you, or I shouldn't give you, and I won't. Like, 36 is an option, 37 is an option. Because that would be cruel. Because our eyes all estimate a little bit differently, and Cambridge even gives leeway for estimation. Because these graphing type questions for Cambridge would only show up like on a lab exam. Then you do graphs and you have to make some estimations.
37.1.
Anyways, so 37 is the amount that We have 15. I'm like, I'm pouring 15 in. Can I predict if it will dissolve? Will it all dissolve? So if it all dissolves, and you can dissolve more, it's unsaturated. The answer here is unsaturated. So anything less than 37 would be unsaturated. 37 would be saturated. And if I tell you something like 60, you should say it never, like no matter what you change the temperature to, you can't get 60 to dissolve, right? So it would still be saturated.
Since bigger than 15 grams, I guess that's
Because the amount that can dissolve is greater than the amount that you put in.
Wait,
It's
so
unsaturated.
what if it was like 40?
Then
like,
it's saturated.
How
Like
is
if you put in 40, it's saturated.
how is it not super saturated?
They have to tell you for it to be super saturated that 40 grams has dissolved. Like if they say in the question, 40 grams has dissolved and only 37 can, that means it's super saturated. So they told you it is dissolved. Like they have to state that as a fact. If they didn't say specifically it is dissolved in it, then you say saturated. Because remember, supersaturation is a weird thing that only happens by altering the temperature so that more dissolves and then letting it sit. So letting it sit, bringing the temperature down without touching it. The second you touch it, all the solid comes back out. I wasn't planning on it.
I just gave her an idea.
But now since we know, she's not gonna do it. But then she will. But then
No, probably not. I get a pretty straightforward test and somehow it's still, you know, bad scores.
hey, this,
Chemistry's hard.
hey, this.
In the front of the class. All right. What other topics? What time is it? We're at 3 p.m. Okay, you're allowed. Let's throw it out and clean up after yourself. All right. What are we doing next? What do we want to look at that we today? And specific one? Okay. Let me pull it up. You said today's one, right? Yes. I might have to write it out. So skeleton equations, number 4. So I'm going to give you a different compound because I'm not going to give you the answer, but I'm going to give you the template of the answer basically, so you have to do it for your own.
It's just
So-
this is decomposed. What does that mean?
I'm going to explain that. So when solid, let's do something different. When solid strontium carbonate, I'm keeping it close to the same, just a different group 2 metal, is decomposed. If I change the polyatomic ion, I actually change everything and I make this question much harder, which I'm not intending to do. Solid strontium oxide and carbon dioxide, that gas, are produced. We want skeleton equation and we want balanced equation. Okay, let's take a look. Strontium carbonate is decomposed. I haven't put over the major types of reactions with you yet, but we did kind of go over like what were the key words. Decompose was one of them. What does that mean? Decompose means what?
When something deteriorates.
Deteriorates, falls apart, right? So they're basically saying strontium carbonate is falling apart. Does that make strontium carbonate a reactant or a product? Before you fell apart, you were a whole, right? So strontium carbonate is the whole. When it's strontium carbonate, it hasn't decomposed. Once it decomposes, it becomes, and they tell you the key word, I think, produced. That key word is here. They tell you that this is produced and this is produced. So these are the products. So we know that if we do our little structure, there's the, remember, reactants on the left, products on the right. Products are now what? Do you understand why strontium oxide and carbon dioxide are the products? Because they are produced. Well, something has to produce them, right? What produces them? Yes. So what you start with is the whole. It breaks apart to become this stuff. What you start with is the reactant. So strontium carbonate is your reactant. Now what? Well, is that everything you need now to make your formulas? Strontium carbonate. What charge? Do you have the cheat sheet that I'm giving you on the test? What does it say? Not -1. There's also a trick on the periodic table. No. Carbonate is a polyatomic ion. -2.
Miss, pencils real quick.
Here we go. Yes. Am I giving you a sheet that has the carbonated CO3 -2? Am I giving you a sheet of paper on the test that says that? You don't have to like pull it out of your head. Yeah. Make sure you use it. Please. I'm sure there's still gonna be some people who forgot that it's there and will suffer. They will suffer. Here we go. Products. What are they? So this is SrCO3. Products are, what's that? Sr plus 2, O minus 2, SrO. And the other one? Because we just know that, because it's a dioxide. I don't have to do charges or anything. That's it. This is also balanced. Count them out, the amounts are the same on both sides.
Wait, do you think this is bad?
What about sticks with matter?
Do you do something good or bad? And 7.
Very good. What do you mean? If they tell you the state of matter, you have to use that. The homework? Which one? Yeah, the one hard. Remember, it's not going to be exact question. Yeah, so try this one again. Try this one again at least, because this one we did 2 questions. Like, not exactly the same, but we actually did 2 questions like this.
Boys Mickey Mouse in the cartoon.
We used that. 15 is rough. I didn't see it. One question at the right.
For a long time.
Okay, fine.
The first one in my head was sort of like.
Try it again. Because we did one and now we did it from where we did. Try that 13. It's basically puzzles. Make the amounts the same. As I said, some people love balancing. Some people are like, they don't say it out loud, but I hear the boo in their head.
You're right. You
They
get
think, like fraction phobic. Brings up a fraction. It's
like,
just like,
one half is not even that bad. It's like 0.5. And then 0.5.
I don't know. I think it's, I don't know how you decide that. When I was in like 2nd or 3rd grade, I learned fractions. Like early, young. I liked fractions. And people looked at me, like 2nd, 3rd grade, I learned fractions. And people looked at me and they were like, how do you know that? I was like 7. And I was like, it comes easy to me. So it was
That's
just
how I
like,
look at them.
it was just, but there's certain things that for some people, and it's just how our brains, I guess, are wired. Like certain ideas are very easy for other people that are very difficult for me to understand. Does that make sense? And then fractions is one of those things for me. It just like was like, yeah, that makes sense.
Also, I think the education system may have evolved because, like, if you were taught fractions in 3rd grade, I was learning.
Yeah, but I had a weird education. I wasn't raised in the education system. I was homeschooled in 3rd grade.
Oh.
So like I taught myself things a lot. So, like when I was little, I was like, I could do this, and then like your parents will help you a little bit, but I pretty much like a lot of times read and reading, and I just got the answers, how to figure it out. So I can't comment on the education system of elementary or middle school because I didn't go.
6.
That is a foreign concept to me. I remember chemistry was one of the first classes that I actually took with a teacher. Because when I tried to read it in a textbook, I was like, that's hard. I'm not teaching myself that.
You forgot to go. I do.
So
4 times 1 is what?
I was like, I needed somebody to like bring that to
4
life.
times 1 is what?
But today,
Now I know a lot.
4, what is 4
Because I did
times 9?
challenges. Everybody's different.
So you're 4.
Then you have 2 here.
What? Everybody's different. Oh, you're capable of more than you know. That's sitting right next
That's
to you.
where you're messing up. Because you're doing oxygen first.
No, I'm doing carbon.
Okay.
So you've got how many? 3 times 2? 6, right? For the amount of options. 3 times 2 is 6. And 4 times 1. Oh, so you got 6 plus 4 is 10.
Okay.
So now you've got one that you can't play with.
You
It's
get
going
ready?
to be 1
Does
plus
it answer
what?
that?
1 plus what? What does this
So I
mean?
get 10.
So,
4, 4, 1. Actually no, I think I do prefer graphics. But decimals like 0.5 are good. Decimals like 0.5 are good to me, but like decimals like 0.11392 is like I prefer the graphics.
Like 2 over 3
Exactly.
is like better than 0.6.
Yeah, right. It just, 0.5, I like it. That's actually the first substitute math that I tried on that note. With multiplying them. Like when somebody will give you like 150.339 times 0.442 and you have to like add all the places. That's the first time I tried in math as a kid. I was like, this is so hard. Because you have to count all the places, you all the multiplications, you can't use a calculator, you have to add the zeros, and it was like so much work. Just to know in real life, you get a calculator for everything. So that's why I have to-
Like in math, she's reteaching us how to like long.
Like,
I use my calculator for that.
But you gotta find like the number for the remainder and stuff like that. That's what I'm saying, like, if, even in a STEM major, like I majored in chemistry, I never did that, like in anything that we ever do in chemistry.
Like sometimes I like to think that, oh, like, yeah, this is easy, but then I'm like, let me double check.
See, that's why I put
I
that.
know, that's why you double check.
You should always check with your
How is it
calculator.
wrong if you got the same answer as me?
Like, here's the thing, you get a job, right? You better be right. Like, let's say you're a pharmacist and you're doing
No,
somebody's
it's because
prescription
you
and you
have
have
to
to
add your
fill like the right amount of pills. You better be right. You better double check. You better not mess up that calculation. So any person will prefer you have a calculator than for you to do it in your head. That's the way that I approach it.
I trust my phone more than I trust me. I trust the calculator.
For some reason, I put one thing, I did the answer, I just 2 plus 2, and I'm like,
Just to
I'm
check.
like 4 myself, and then I'm like, oh, really, is it? And then I put it on the calculator, just be
I do
sure.
that too all the time.
Just be sure. And I think on the new FSA math, they allow you a calculator for everything, right? Yeah.
how is space?
That's nice. I've never had a single math class in college or university where they said you couldn't use a calculator. Every single one, they allow you.
What's it called? The algebra, like EOC or something, like, on the topic test, it was like, the first one was that no calculator and then calculator. But, then now they
But I
changed
think they
it to
even
all
changed the
calculators.
SAT that you get a calculator,
Yeah.
right? I think they're starting to get with the times, but they're like, in real life, people use calculators.
Yeah.
It's good to have skills, like times tables. Why do we need it? Where do we need charged carbon? We don't need it for this, carbon dioxide, CO2. Oh. Right? Oh, yeah. Because it's covalent.
Plus 2 minus
So CO2. No charges here.
Okay, Mickey Mouse, we get it.
Wow.
Ooh.
Wait,
I asked Mr. Garcia to come back when we did the lab, right? And he came back when Ace was doing the lab, and one of the students broke up because he was there. I wonder if they were nervous that he was there. I was like, it's okay, it's okay. Because it happens. Like,
Wait, when?
I was like, I told Mr. Garcia, this is the reality. This is like what really happened.
When today?
Yeah. Because he
Oh.
watched our class today. What?
Is it surprised?
Yeah, he was watching our class today in fourth.
He was surprised.
And then
I did not.
I told him if he wants to see a lab to come in sixth because we're not doing a lab today in this class because I teach all the different classes. And so he came back, and one of the students accidentally, like it wasn't on purpose, it happens. People make mistakes. Like they accidentally lifted something and it fell out. Fingers slipped, exactly. So we cleaned it up, no worries. I was like, that's the reality of chemistry. That's what it really is freaking out, messing up on your labs, and like.
I literally have like 2 left.
bruh.
Wait, man.
Cambridge exam? Yeah. We'll replace it for you. The only thing that happens is emotionally, will you be okay?
No.
Because like it rattles you.
I think
Like, will it like mess up your? Yeah, I feel like you want to try not to do that just because I think that the worst thing is not necessarily that happens, but how are you going to be emotionally affected by that afterwards? Because I know for myself, anytime that I ever broke something,
Oh, come on.
like I will feel real bad. Like, and it would
so
stick in
much
for
acid.
like a while.
Liar, liar, pants on fire.
Like,
What?
yeah, he was just like,
I
guess he was a little surprised. He was
Wait,
Positive
He was in a class today?
Yeah.
I never know. I
Mr.
never
Garcia
know.
was in your class for like 20 minutes today.
I never know.
Yeah,
I
these
didn't wanna
three, I
announce
think they had the plus charge and aluminium.
He's actually a ghost.
I don't teach differently whether he's here or not. I'm gonna-
One day you need to come in with the ears. Look at him, look at him.
Yeah, he told,
principal.
yeah, they were in my second period, they came in second, I think it was Monday, I think they were just checking that everybody was. I think they were just checking to make sure everybody was. I hope everybody was done. We're in school. But my husband works at a different school, he said that they also went to every class on Monday, so I don't know if they're just like, go check every
Not
class
for them yet.
the day after. They could also look at the uniform. And I do. No, if admin's ever here, you just do the same thing as me. Like, I don't ever stress it because they're here to see our school, they're here to help us, they're here to support us.
Yeah, I'm like,
They are.
they might seem
Wait, what do you say when
Scary.
a
But they're
little
here to
scary.
support you.
They're helpful, very helpful.
Like, they're not gonna get on that student that accidentally broke something.
What do you say whenever I broke?
What?
What do you say whenever?
No, he just had a face.
Oh.
He's like, but I said it was okay. Like, mistakes happen.
Wait, so who buys it? Yeah.
I mean, we have like from your lab fees, we can buy some of the broken glassware with that, and then I also have a fund for like the ACE exam, so I can make purchases for that, and then anything above that, I usually pay.
Oh.
Like for anything you need that goes above and beyond the lab fees and the ACE exam things, I'll just buy.
Wait, can I put it on the opposite side, like the arrow facing that way? But like,
But that's why you pay your lab fees is for like chemicals and for broken, like it happens. There's just certain glassware, please don't break it. It's super expensive. Like a beaker's okay, that's what was broken today. Like it's not a big deal, it's like $3. Okay. Your lab fees more than cover that. But if you break like a $30 thing, we're not like it's okay, but it hurts my heart. Because of money. I always joke with the ACE class that when they break something, I just see the money fluttering. I'm just like,
Instead of the
I just see the money just coming out of it.
I mean, if I ever break something, I'll like bring one up.
You don't have to. Somebody last year in pre-ACE, they thought that they had to like replace it, like they had to buy it, and they were crying. Please, it's okay. Like, please don't. I know you feel bad, but It's okay. It's
Imagine
okay.
somebody started crying in their chemistry exam.
Has that ever happened?
Like the two dropped into physics.
That'd
That'd be so. That'd be
dropped into the beaker and like
That must have been a rough exam. If
It'd be
they're
like,
crying.
Wait, this is
the
the
ultimate
ultimate
tragedy.
You
tragedy.
have to do this.
Oh yeah, no. Shakespearean.
Can I put the comments on this side? That's so bad. That's so dumb.
No.
Like why?
Stop.
No.
Not in this country. We read left to right, not right to left.
How many times?
You have to go 78 times.
I think this is
Come on.
this number I think is
Okay, let's go, Sarah.
good. The nitrogens are
We're
these.
not going to lactation.
Let's go who?
Until lysation.
It's so dumb.
A
I don't know how they fall for everything.
There was a sound
What are you trying to do? There's three here.
Oh yeah, we have a quiz tomorrow.
Oh, I can't believe it.
Algebra.
Oh my God, Sam. Sam, you.
No, and then you're in the car being like, oh, what do we have to do? What do we have to do? Mom, I forgot. And then we stay quiet, and then you're like, I don't know.
It's like the Wicked Witch of the
And he
West.
goes crazy if he doesn't know. Like, for real, I know we told you.
I would say.
And then you guys get in that.
Like, have you ever watched The Wizard of Oz when they throw the water and everything?
Oh, yeah.
Okay, miss.
Are you good now? You feel a little bit better about
Yeah.
the different stuff? You're gonna study those practice questions?
Yeah, are you gonna post them to
I'll post them today, but after I clean up the lab and everything.
Okay. Oh, that's not interesting.
Yeah, we were measuring heat.
Looks like.
Oh.
I like how chemistry papers look like aerospace engineering after I'm done.
Like if you show it to somebody who hasn't studied chemistry, they're just like,
Yeah, like my.
That was me last year.
oh, if you have friends who took it and they show it
Yeah.
to you, you're like,
You're like, huh, I can never do this in my life.
"Whoever thinks that until you
My mom never took chemistry. Yeah, they just showed it to Ryan. And she sees me doing my homework. She's like,
Whose pencil is that? Yours?
How many?
very rough.
it's people that were.
How many? Because that's the thing. How many?
That's a dumb question.
Asked.
How many?
How many what?
0. Entities.
Entities. You're talking about entities. Okay, look for it. Look.
Okay, yeah.
Bye, Sarah. Bye, Sam.
Bye.
Try it now. Yeah. Because you had parts of it.
Yeah.
Here, like, so for this one, you do, because not only is nitrate here, it's also, like, the and the oxygen are also here, so it's in two different spots, so you have to separate. Into nitrogen. That's why it's weird. So, that's why there's so much. Where are you going back?
I looked at the first one and I tried the first one. And I was the second half for like 15 minutes.
I told you, I think I told you.
Yeah,
all.
you told us. You were like, if you're there for more than 20
Please don't.
minutes, don't.
That was just to give a helpful guideline because I know.
Yeah.
Because I know that these questions, like, especially a lot of times when you see me do a question, it'll seem like, oh my God, she did it like that. But that's because I already
Like, you know what
know
you're doing.
it.
And you know
When you're learning it, you don't know what necessarily are the pitfalls or where you could make mistakes. So I said, if you're sitting on a question, it is 15 minutes, I don't care, even in an ACE class. The homework shouldn't take that long. If you find that it's taking you hours, some students, what they do is they just come to tutoring and they do their homework in tutoring and then they get it done in like 30 minutes. Because it works, right?
My hand is so sweaty.
Okay.
She does that to me too.
But that is my suggestion. Like if you're sitting on any question for longer than 15 minutes, you're fine.
Yeah.
I would rather you save your mental effort and then just ask me. And you might find that I know something that could help you out. That would make it a lot easier.
Like on the normal questions, like finishes are normal performance. So like she sends me.
How long does it take you to do the normal question? Just so I have an idea.
30 minutes.
Okay, that's fair, that's fair.
I did it in a different class. So yeah,
No, because I don't try to give, even in the ACE class, like I said, I don't try to give homework that's too long.
it's not.
But I try to give homework that's like helpful.
Yeah,
Like,
yes,
are
it
the
is.
questions that-
Once I do it, I feel like I forgot
You get it
how
back,
it
yeah.
concrete.
So if you're spending like 2 or 3 hours a night on homework, like, that's not the intention. You're not supposed to. Now, when we get to the math, it might take a little bit longer because there's problem solving. Math is
Yeah, math is evil. Math is evil. I always used to joke with him some morales around.
I think I told you on class, I'm like, it's quarter 3. It's quarter 3. It's coming. We are close
Yeah,
to the math of it.
it was already about to end.
Yeah.
Like it just started.
And I was like, think about it. I was like, with the new year, it goes by, January's like 2 weeks long.
Yeah.
Because we don't start till like January 9th or 8th. And then next week, I see your class
We only
once.
have 3 days.
I see your class once. Like, how much am I gonna cover in one class?
Yeah.
And so like, January, the week after, that's like the last week of January.
Yeah.
So I'm like, well, that's it.
And then all the
And then February, March, April go like super
But like
fast.
those are like the stressful months.
Those are the hard months.
Because the tests like April.
Those are the hard months, and it's also hard here because, like I said, everything builds. So
Yeah, so it starts getting more.
it starts getting more, even like the skeleton equations, you start seeing, oh God, that stuff that I learned before, it's all
Yeah,
like
the
the
crisscross.
carbon
I was like,
dioxide, the
oh.
crisscross, the poly, it's, oh my God. Like, that's why I said, I mentioned it before, that as the year goes on, it does get more difficult because it all kind of adds together.
But it's
It
good
is.
'cause then you like refresh it.
It does the good part of that is you're constantly
Like
going back over the
yeah.
things that you did
Like, oh
before.
yeah, I learned this.
We did do it, but let's go over it again.
Yeah. Oh my God, this is so cute.
It's
so
my calculator.
It's so yes,
That's my favorite calculator.
It's so pretty.
Have a great day.
You too.
Remember, you got that 5% on the extra credit for the test, so you know you got a 5. You can max out at 125 now.
Well, I'll finish this at home and
Okay.
I'll take a picture.
And I will
of it.
clean my laboratory. That's the next thing.
Oh boy.
Then I will post your quizzes. Then I will go home. I also have to post your notes that I recorded in your class. Yeah, I don't know if Mr. Garcia was like observing for like my official observation for the year, because I was gonna send him last year. I sent Miss Ledesma like our class recording, but it would be for last year's class. I was like, hey, if you want to see like the whole entire class, like I record it. So here you go. They're always like,
First day when you said recording the class, I was like, what? Is she gonna like set up a tripod over here and like?
no, I just record like the sound of what I'm writing so that you have the problems that have been done. No, like I don't know that anybody else does that.
Yes, it would be like.
But it is because number one, we don't really have a textbook, or there's an online textbook, but like we don't really have a textbook. So what you get here is like all the content you need to know. And so sometimes when you're in class, you get it in class, but you go home and you're like, oh my God, I forgot. And so that's why instead of having like a textbook, I just post all of the notes with the recording so you can go back and see the processes over again. And so there is a purpose. There's a reason behind it.
Everything has a purpose.
Yeah.
But like
It's
I'm.
just a little bit. It's not that much more work on my end. It's just a little bit more that I have to. You see me setting up for the next class a lot of times.
There's always some good news. For example, I know this friend of mine, Daniel. He's a freshman.
Yeah.
He really, really likes math.
Oh, good.
So I've been like talking to him about the very, very great chemistry teacher we have at CIE, and he's like,
Appreciate kind words.
and I've showed him like. the
My
line-
husband, Mr. Braun, said you would most likely like this class a lot. Because there was a math teacher that maybe he worked with you, and she was very strict, but she explained pretty well. And he was like, oh, he'll love your class. I don't know. He was an interventionist, Mr.
Yeah, he was an
Braun?
interventionist, but, Miss Dieguez was the name.
Miss Dieguez, yes. He mentioned her name.
She brought him up, and then he walked in. He took us away to another room in a different
And you
part
guys
of
would
school.
study with him.
Yeah,
So
the
kind of
library.
like what we do here after school, he will do with you, like during school.
And it was
right?
surprising because then like what Ms. Dieguez took for like 30 minutes to explain, he could do it in like 2 seconds. It was like He was helping a friend of mine next to me, and I overheard, and it was like, wow, that quick.
And he told me that some students made that comment too. But that's because, you know, both me and Mr. Braun, we were math tutors at the college. Did he tell you that? He was a math tutor at Miami-Dade College for many years, and so was I. So like, when you're a tutor, you figure out where students don't, like where the issues are.
Ah.
So, like, in a tutor, you can ask a student one-on-one, you're like, what don't you understand about this? What don't you understand? Like, you can kind of really get a good idea. And so that's why he's very good. He excels at explaining math ideas.
Yes,
So,
I remember.
yep. And we're both like STEM people.
In fact, I think like what he did over there, like in the board, in the little room, in the back of the school's library, it really helped out on the final day, on the final exam. It really
You
helped out.
remembered a lot of the stuff?
Yeah. So
Yeah.
I thank him really.
He's gifted in it. That's, you know, a talent. And he still works there, but he's not an interventionist. He's a teacher.
Oh.
Eventually, he wants to teach math.
He got hired by the school someday, man.
He got hired by the school. He's teaching, have you heard, like, of inclusion classes? They're called, like, for autistic students, ESE students, where they have their own class, where he can really just be like an individual one-on-one, really help the students out.
Oh.
He does that, but as a full-time teacher now, like he's the lead teacher of the class. But it is small groups because for those students, they need more help, like interventions, so they're in small groups. So he does do like kind of a similar thing. The only thing he's not happy about is they have him in 5th grade, and he doesn't want to do 5th grade. He wants to do like older, like middle school. He doesn't want to do elementary school.
Yeah, I know.
So he may change it hopefully for next year.
Well, I gotta go.
Bye.
Bye, miss. Enjoy your day.
Have a great day.
Good luck making the test tonight.
What?
Good luck making the test.